So in this question, a car starts moving from rest on a horizontal ground such that its position vector of the car with respect to the starting point is given by this equation, where a and b are the constant and unit vector I and unit vector j are along perpendicular axis, that is x and y, intersect at the starting point of car, that is at the origin. So here we are going to find out three things. First, of the equation of a trajectory of a car, that is y as a function of x. Second, the angle between direction of velocity and acceleration of the car as a function of time theta is the angle, and it is to be found out as a function of time t. And last, we are going to find out average velocity of the car over the first t seconds of the motion. So in this case, it is given the coordinate of the car. So suppose this is the x-axis and this is y-axis, and this is given as a position vector represented by r, and it will be drawn something like this. So it is going to have two coordinates, x coordinate as well as their y coordinate, and its vector, position vector, is given as b t unit vector I minus, it is given a minus, let me draw it again. Okay, so we have x-axis, y-axis, and this is minus y and this is minus of x, and it is given that position vector, so it will be in this direction. Let us say r is equal to bt I minus ct square j. Okay, so this is the basically position of the car represented by unit vector. So this is the origin. So here we are going to find out three things. So in the first, it is given that the position vector of the car. Okay, so it is given that position vector of the car is given as r is equal to bt unit vector I minus ct square unit vector j. So from here we can find out their x coordinate as well as y coordinate. Okay, so we can see that the x coordinate of the car, x coordinate of the car is equal to bt. Let us call this as equation number 1. And y coordinate of the car it is given as ct square. Let us call this equation 2. So in this, from using equation 1 and 2, we can find out that what is the relationship between x and y. So we can write that x is equal to, x coordinate means x is equal to bt and y is equal to ct square. So by eliminating t, we get y is equal to c b square x square. Okay, this is first part in which it was supposed to find out equation of trajectory y as a function of x. Okay, so this represent y as a function of x. This was our A part, sorry. In the B part, so from the first and second, or rather we can say again we are going to use equation x equal to bt and y is equal to ct square. We can find out the component of the velocity with respect to x-axis. So we can say vx, velocity component in x-axis, will be given as derivative of this, so it will be b. Similarly, we can find out vy, and that will be coming as 2ct. In the vector form, it can be written as the vector form. We have the velocity is equal to b unit vector I plus 2ct unit vector j, and from here we can find out its magnitude. We can say magnitude v will be equal to b square plus 4c square t square and its square root. Okay. Next, we can find out the acceleration in x-axis as well as y-axis. Okay. So we already know that velocity vx is equal to b and vy is calculated as 2ct. So from here we can find out ax, which will equal to 0, and ay will equal to twice into c. Okay. So in the magnitude form, acceleration ax is 0, so we get only 2c unit vector j. Sorry, it is vector form, my mistake, vector form. And in magnitude form, we can find the magnitude will be equal to a vector is equal to 2c. Now, in order to find out the angle between the velocity vector as well as the acceleration vector, okay, what we do, we find out their dot product. So to find the angle between velocity v and acceleration a, taking dot product. Taking dot product. So if theta is the angle, if theta is the angle between them in time t, we can say that their dot product a vector dot v vector will be equal to a magnitude v magnitude cos of theta and we already know that A is given as 2Cj dot Bi plus 2Ct Bi plus 2Ctj is equal to, the magnitude of A is given as 2C and magnitude of B is given as B square plus 4C square T square and its square root multiplied by cos of theta. So from here we get cos of theta. The dot product will be coming as 2Ct divided by B square plus 4C square T square and square root. And we have last part, that we find out the last part, find the average velocity. Okay, C was average velocity of the car in first t seconds. So we can write average velocity V average will be equal to displacement vector at time t divided by the time taken, that is time t. So we get this as BTI unit vector I plus CT square unit vector j divided by time t. Okay, so t cancels out, so we get V average is equal to Bi plus Ctj. So this was the average displacement vector at time t, and we get the average velocity. Okay, thank you.